Hey everyone, and welcome to The Explainer. Today we're going to talk about something that's super important, but honestly often gets overlooked in a machine learning project, actually understanding your data by looking at it.
Okay, let's just jump right in with this quote. It's a pretty serious warning, isn't it? And this isn't just some random advice. It's pulled straight from Chapter 5 of the guide, and it really gets to the heart of the matter. Raw data on its own doesn't tell you anything. In fact, it can be totally deceptive, hiding the very patterns you need to find.
So how do you do that? How do you avoid those traps? Well, the trick is to turn those numbers into a story you can actually see. And that all starts with having a solid process. It's not about just randomly making charts, it's about systematically exploring your data.
So, where does visualization fit into the bigger picture? Machine learning isn't just about throwing a bunch of fancy algorithms at a problem. There's a whole structured journey to it. A really common roadmap is something called CRISP-DM, which is short for the Cross-Industry Standard Process for Data Mining.
Now, what I think is so interesting here is that step 2, right after you figure out the business problem, is data understanding. That's what we're focused on today. And notice, it's a formal, critical step. It's not a suggestion. This is the part where you got to put on your detective hat. You have to be skeptical and really dig into the data before you even think about building a model.
Okay, so how do we actually do this data understanding step? Well, we've got to make our data talk to us. And honestly, one of the best and most powerful ways to get started is with a really simple, classic chart.
Let's kick things off with the histogram. Think of it as a quick personality test for your data. It just groups your data into different buckets and then shows you how many data points fall into each one. It gives you an immediate feel for the shape and personality of your dataset.
And this is a perfect example. We're just bucketing people by age. And right away, you can see that most of the people in our data are in that 21 to 40 range. It's a super quick visual snapshot that is way easier to understand at a glance than just staring at a spreadsheet full of numbers, right?
And this is where things get really interesting. Because seeing that shape isn't just about making a neat picture. It's about being a data detective. It helps you spot problems, maybe huge problems, before they completely wreck your model later on.
Because here's the deal, that shape tells you a ton about potential problems down the road. You see, that perfect, pretty bell curve is actually pretty rare in the real world. A lot of the time, your data is going to be lopsided or skewed. And that can be a big issue, because a lot of models secretly assume your data is nice and symmetrical. When it's not, the model's predictions can get pulled way off track.
So over on the left, that's the ideal, a nice, normal distribution. But on the right, that's what you're probably going to see. That's a skewed distribution. A classic example is housing prices. Most houses fall into a certain price range, but then you have a few mega mansions that pull the average way up, creating that long tail. And this is such a common problem that the guide actually has a section back in Chapter 4 all about data transformation techniques, like using logarithms, to help fix this exact issue.
Okay, so we've talked about using charts at the beginning. But here's the thing. They're not just for your first look at the data. They are also an incredibly powerful tool for checking your work after you've built a model.
This might sound a little technical, but the idea is actually super simple. We just want to visualize our model's errors. We're basically asking, are our model's mistakes just random misses, or is it messing up in a predictable way?
Yeah, residual sounds kind of fancy, but it's really just the error. If the real answer was 10 and your model guessed 8, the residual is 2. That's it. We're just giving a name to how far off each prediction is.
So when you plot all of these errors, what you're looking for is, well, nothing. You want to see random noise, just a cloud of dots scattered around that zero line. That's a great sign. It means your model figured out the real pattern. But if you see a shape, like a curve or a funnel, it's like a giant flashing red light telling you, hey, my model missed something really important here.
All right, we have covered a ton of ground, right? From that first look at our data with histograms all the way to checking our final model with residual plots. So let's wrap it all up and talk about the main story here.
So when you boil it all down, what's the big takeaway? It's that visualization is not just about making pretty charts for a PowerPoint deck. As we've seen, it is an absolutely essential tool for investigating your data, diagnosing problems, and validating your work. It's how you go from just having data to actually understanding it, which lets you ask better questions and build way better models.
So here's what I want you to take away from all this. Learning to see your data is the very first step to truly understanding it. So don't just analyze it, visualize it. Thanks so much for joining this Explain.